Okay, we're going to look here at what I think I've shown before in my slicer program. But if you look at something that's printed long ways and the layers just make up the thickness of it, you're going to have a lot of strength, because imagine stacking a whole bunch of layers of plywood on top of each other and then the bending forces. But you have to keep in mind the height of the object is going to basically give you kind of your strength because of the thickness. But keep in mind, as this is extruded lengthwise, think about it as layers. Okay, so if you use an ABS or PETG, whatever the material is, it's how well it sticks to each other that kind of gives you your strength over the length of this. However, and think about this for a second, when you start depending exclusively on the adhesion of each layer, it's not a continuous melted piece. So lengthwise, that's basically melted together extrusions that run the length of the item. Now if you look here, as I stack these, the only thing that you're depending on in the adhesion is however well the material came out of the extruder and then melted to the other layer. So all the strength in this piece I'm showing you here that I'm going up and down with depends on how well the material stuck to the other material as it comes out of the extruder. So lengthwise, you have a whole bunch of layers almost like plywood, and that's where you're going to get your strength. But when you're going to go vertical with the piece, it's completely on the adhesion. Okay, let's look at this test right here. This is nylon, and the layers are running the long direction on this. And as you can see, it's very strong. As I kept applying pressure, I would hesitate for a couple of seconds to make sure that my load sensors caught up with my little processor that I put together here. But I wanted to see how high it would go before it started to have any degradation of the material. And on this particular part here, I got to 72.4 pounds before it started to actually fail, and you know, the structure started holding less and less and less. Most important thing to keep in mind here is imagine a whole bunch of layers of little micro plywood, and that's what I'm pushing against here. Nice thing about nylon is it just bends. It never completely shatters or fails, at least with what experience I've had so far. Here in this picture here, you're going to see that the nylon basically started to pull apart at the bottom. Most important thing to keep in mind about nylon is you've got to run it really, really hot. And I ran mine at about 270 C. Here you can see where it started to pull apart, and you can see the layers that are bending there. So I think this was a very successful test of nylon when it was extruded and lengthwise of the part. If you look at this next video here, you're going to see just how fragile it is in the other direction though. See, that nylon didn't even hold hardly any weight at all. If you look at the part here, it looked like they weren't even glued or adhered together at all. So my nylon was still not hot enough at 270 C. I'm going to crank it up to about 275 or 278 in my next test. As you can see here, you can see each individual layer in there. There's hardly no melting together of the material. And this isn't good. This is kind of a failed test right here of this. In this next test here, I have PETG, which I extruded 260 C, and this was really strong. I was really, really happy with how it worked in this direction that it was extruded. This went up to 83.6 pounds, and I was extremely happy with this test. So far, the nylon lengthwise and the PETG lengthwise are very, very strong. And this actually got up to 83.6 pounds before it started to show any failure of the material. I do believe I could run this a little bit hotter and still get a little bit better performance out of the material. When you look here, you can see that it actually stretched the bottom of it and buckled the top of it slightly. I'm not sure what this really means yet. I'm going to do more testing with the PETG, but anything that went to 80 pounds. Now keep in mind, this is 10 by 10 millimeters by 100 millimeters long. Here's a little bit closer shot of it. I'm very, very excited with how this material worked. in this next PETG test, I was actually quite amazed how well bonded each layer. This test here will show that where the other materials have failed really quickly, this went to 26.4 pounds before it popped apart. And I thought that was just extraordinary on how well PETG stuck to each of the different layers. Again, I go slow to make sure it can be registered right. Here you can see basically what the PETG looked like when it separated. I was still extremely happy with how strong this was with layer-to-layer adhesion. So far, this is the best material I have tested yet. On this close-up here, you can actually see where some of the individual layers tried to stick together and where they actually were melted together. It's not 100% adhesion, which means I would like to turn my heat up just a little bit more and see if I can get these to melt together. Next, I tested the carbon fiber ABS. This is ABS with carbon fiber impregnated in it. I was really kind of disappointed at first with how brittle this seems, but the strength versus the weight of it is really nice. So I don't want to knock it too bad because it did get to 80 pounds before this started to deteriorate and fail. So overall, I'm still not completely convinced with how good of material this is for me, but it's really cool looking. If you want to have nice looking parts, it's really kind of futuristic. So as you can see here, basically in tension, the bottom layers pulled apart and the other layers then buckled. And as we zoom in here in just a second, you'll see that right here, you'll see that basically in tension, the bottom layers pulled apart, so they ripped apart. So I thought this was a pretty good test, and I'm still amazed how strong this stuff is extruded. And here's the weakness of the carbon fiber, but I believe most of this is due to the fact I just didn't have it hot enough. I mean, it just fell apart literally at 6 pounds, and I was not happy at all. What's really interesting here is that it looks like it just didn't adhere at all to each other, the layers. So they recommend 240C, but that's nowhere near hot enough to get proper layer-to-layer adhesion. So I'm just going to have to crank it up. As you can see here in this picture, it just looks like they were both printed separately. So I need to really crank up the heat and see if I can get these to melt together better. And in my last test here, essentially I took ABS and ran it at 240C, and I was very excited that the ABS was one of the strongest that I tested. It went to 95.4 pounds before it failed. I'm still not completely convinced once I do these tests right and I get them extruded at the right temperature what's going to be strongest. I still think the nylon will end up being the strongest once I learn how to get the temperatures right on it. But out of this testing right here, my without a doubt, my ABS went to the highest limit before it started showing failure. So at the 95.4 is where it started to basically go back downhill, and I just kept cranking until you know, it just snapped. So it's an interesting test here. The ABS, a lot of people say, is one of the hardest ones to print, but for me it's been the easiest. It's stuck to my table well. I mean, my heated bed. It's just been a blast to extrude ABS. Here you can see that in tension, the very bottom layers failed, and then you know, it broke all the way up to the point that it bent, and by then it was basically useless, so it wasn't registering any kind of strength. Now, one of the things about ABS that surprised me was I thought I'd be able to get a lot better adhesion layer to layer here, and as you'll see, I only got up to 6.8 pounds. This tells me I should have had the ABS set a lot higher. The 240C that they recommend on this is the lowest in the market for this type of 3DX Tech ABS. I still think if I took this ABS up to probably 250 or 255C, it's going to stick a lot better. But as you can see here, it just fell apart at around 6 pounds. So I wasn't happy at all with how the ABS stuck layer to layer. Now, if you look close here, you can actually see the other layers really didn't stick together. You can see where it parted there. But if you notice, the other layers show little bitty gaps in them. So to me, the ABS just wasn't anywhere near hot enough, so this isn't a valid test.